Good afternoon, students. I am hoping that we're all doing well in this time. I know some of you might be out, back to school, face to face, but welcome. Welcome to the Ministry of Education, Youth and Information. Good afternoon, students. I am hoping that... Yes, So we are here again in the series of workshop, and we will be looking today at linear programming. No, Tyrone, Mr. Brown. So my co-presenter today is Mr. Brown. Mr. Brown, how are you? Good afternoon.
Good afternoon, Mrs. Edwards. How are you?
I'm good. I am good.
I'd quickly want to give a shout out to all the persons who are with us today on YouTube. It's a pleasure to have you with us today, and feel free to engage with us there. We are definitely checking your responses and feel comfortable and a part of what we are doing today.
All right, so we don't want to echo. So because we're monitoring both YouTube and the Zoom platform, so what I did was to just mute my YouTube platform. All right, so let's get right into it. So today your presenters are Mrs. Cameron Edwards, that's me, and Mr. Tyrone Brown. So what is it that we're going to be doing today, students? At the end of today's session, you should be able to use linear programming techniques to graphically solve problems involving two variables. Now, Mr. Brown, take us through. All right, so before we get to the prerequisites, here are some items that you must make sure that you have today. Make sure that you have writing material, also graph paper, because we're going to be doing some graphs, and your calculator. So once you have those, you are ready for today's session. Mr. Brown, take us through the prerequisites before we begin.
Thank you, Mrs. Edwards. So for today's session, we are hoping that students will be able to translate between algebraic symbols and worded expressions. They should be able to also be comfortable with their graphical work, so they should be able to graph linear inequalities using at most two variables. So, but guys, don't feel anyway if you're not mastering all of these yet. We are here to guide you and to help you if it is you're stuck at any point in time. So we launch into our first discussion. I know you guys, some of you are back at school, happy to be back at school, engaging with your friends, and you get your lunch money and you're able to go and spend it as you normally do. And I know a lot of you like patties, right? So let us look at the situation. Ashley got $300 for her lunch, and her younger brother, Jerome, received $100. I want you to write an inequality in the chat, which represents the relationship between the amount of money Ashley received and the amount of money Jerome received. So I'm looking forward to your responses in the chat. So use an inequality to represent the relationship between the amount of money Ashley received and the amount of money Jerome received.
All right, Mr. Brown, I'm seeing Casey. She is first out of the blocks. So she has a representation here. And what I'm reading from the chat is that she has 300 greater than 100.
Yes, so we are seeing Casey in the chat. Are there any other responses?
Amanda likewise have the same, 300 greater than 100.
Okay, beautiful, beautiful. You guys are doing awesome so far. So we have some students in our scenario who were having a discussion One person said, as you did, 300 is greater than 100. But Tiffany also said 100 is less than 300. And there was a little bit of disagreement between Tiffany and Kelly, right? What do you believe in terms of the chat? Do you agree with Kelly or Tiffany, or are both of them right in this scenario? So type in the chat, who do you agree with? Tiffany, Kelly, or do you agree with both of them?
All right, sir, may I go? So I'm seeing a number of them saying both. We have a very bright group here. Right, so from very early, I want to shout out to Camelia White. She actually gave us both before this came up. So what I'm seeing here, she represented it both as 100 less than 300 and 300 greater than 100. So a number of students here, sir, they are saying both.
Okay, so I'd want to hear why it is both would be accurate, because they look a little bit different to me.
All right. To share from what's there in the chat, I'm seeing where 300 is more than 100, that's Casey, and 100 is also less than 300.
Okay, so what you're basically saying, you are seeing it meets both conditions, 300 being more than 100, while 100 still being less than 300. And you're absolutely right. And it depends on your perspective. If you are taking it from Ashley's perspective in terms of how much money she had, Ashley had more money than Jerome. But if you look at Jerome's perspective, he's thinking that he has less money than Ashley. So you are all doing also well so far.
Awesome. Not seen anything yet. The YouTubers, they're coming up and they're giving the same responses, just as what was shared in the chat.
Okay, so let us see if we can extend this discussion a little bit further. Ashley and Jerome combined their money to buy 2 beef patties. And we are seeing 2 lovely beef patties here that are kind of getting me a little bit hungry right now. But they're buying 2 beef patties, and they want to know how much it is that they can afford to pay for each patty using the 400, using the money that they would have had pulled together between the two of them.
All right, so students, how much do you think, if they combine the money, could be the cost of one patty? Let's see what you have in the chat.
How much could they be able to afford?
Yes,
Okay.
How much do they afford? All right, so I'm seeing persons just blazing up the chat here with $200.
$200. Yes. I'm seeing a 20.
I saw the 20 as well. I've seen 100. I'm seeing 180 by Chevelle and Delangeau. I believe if that's the correct pronunciation. That student gave us $100. It would be good to know why they selected those, since it's different from the $200 that kept coming at first. All right, Mr. Thomas said it was a mistake, but that's okay. We will discuss it. All right. So,
and we're saying, what is the maximum they'll be able to pay? You're saying the maximum is 200, but would they be able to afford, they were less than 200 each? So that's the question. So Chevelle, let's hear or Serena, or one of those who said something apart from 200, let's hear your thinking why it is possible for them to afford patties costing 100 or 180 or other figures apart from the 200.
All right, I am seeing, sir, while we're giving Serena the chance to speak, I'm realizing that on YouTube, we have an Antonia Brown who said $300. And Jackson, is it Carissa? Carissa is saying $200. So it's interesting to see why a student would have said $300. So I am liking what is happening here in the chat.
And I'm also seeing Carissa saying, no, it couldn't be 300. So I'm definitely seeing some thinking going on as in what it could be and what it could not be. And we'll have a little bit of discussion on that, right? So we would have seen so far that it definitely could be 200 because if the patties cost 200 and if they're buying two of them, the total cost would be 400. But, okay. I'm seeing something in the chat, 200 would be the maximum amount they could pay. Okay, and I'm liking the fact that you're starting to use some of the terminologies, the maximum, 200 or less. So Chevrolet is saying, yes, it could be 180, right? Because if you put the money, the cost together, 180 plus 180 is 360, and they would be able to afford it if it is 360 for both parties. So thank you very much for your participation. So we are seeing that it could be 200, could be 180, could be 70, but I'm liking the discussion on the YouTube about the 300. Why couldn't it have been 300?
Yes.
And shout out to Carissa in the YouTube page. But why couldn't it be 300 for each party? And feel free to raise your hand if you want to speak and open your mic.
So if they raise their hand, we will allow them to speak. All right, I'm seeing where they're saying that because 300 is greater, when you probably add 300 plus 300, it would exceed the amount of money that they have combined together. So I'm seeing where Abigail says it could not be $300 or more because of the amount of money that they have. Very good. Okay. All right.
So I'm liking the thinking that's going on. So we already established that the maximum they can pay is 200, right? 300 would be too much because that would be more than the 400 they currently have. Okay, so if it is that we wanted to model this in terms of algebraic inequality using algebra to model it, we would come up with something like this. 2x, where x is the cost of one party, would be less than or equal to 300 plus 100.
All right, sir, can I just want to, what if the total cost of the patty was $300? Because I see where Antonio is asking that the total, that could have been the total. So if $300 was the total cost for the two patties, then it therefore means that the cost of one patty would have been 150. So it still would fall in the conditions that we have in terms of the total amount of money that they put together. All right, very good job, Antonia. I want you to feel comfortable in sharing on YouTube. Over to you, sir.
Yes, so I know they would have started that discussion. So we would have had it so far. Good. So if it is that we had this expression, we can go ahead and simplify. We could add the amount of money that they had, which is a total of 400. That would lead us to 2x being less than or equal to 400. And if we divide both sides by 2, as we would normally do when we're trying to find the unit cost, we would get the cost of one party, which is represented by x, having a value less than or equal to 200. So very good job so far, everyone. So let's see how we would represent this on a graph. when it is that we are speaking of cost and we are looking at this graph, Mrs. Edwards, why is it that we wouldn't have had our standard graph with our negative and with our negatives on the graph?
All right, sir, what we're seeing here is that the graph is in the first quadrant. However, because we're referring to costs, we cannot have a negative value for the cost of the patty. So we're really looking at the region that is in the positive side. So if we're going to be graphing the cost of one patty, we realize that we will use, because we don't have a negative value for the cost, then we will be using that side of the graph.
And I'm also hoping that our students are noticing something special about this graph. I'll ask them to respond in the chat quickly. What special do you notice about this graph versus a normal graph that we would normally plot for a linear graph?
The normal.
Or for an equation? There's something unique going on here.
I'm not seeing them. Okay, one student is saying that it's shaded. All right. No negative numbers. Okay, thank you, Victoria.
Okay, so no negative numbers in this situation because of what we were discussing earlier, and it is shaded. So that is a part of our discussion. When we are talking about the graph of inequalities, it's not a line, but rather a region we are speaking of. So as you can see on our graph, we have something shaded, a region that is shaded. And that represents all the possibilities for the cost of our patties. And I'm hoping everyone is seeing that. Let me put up the spotlight. So you're realizing that we are talking about all of these as possible costs for the patty, right? So the patties could cost 160, 120, 80, and so on. And in an ideal world, the patties would cost $20. So when we are talking about inequalities, we are talking about our region. Good, and I'm hoping the students are seeing that, and they did.
Mr. Brown.
So, yes.
I want to speak of Odane Grant on YouTube, who gives the who said that it stops at a constant number, which is 200. So I noticed that he spoke about that the graph is at the 200 mark on the x-axis. Very good.
Okay, that's a very good observation. So let's also look at a situation where we have this graph. And let us see what this graph would be possibly saying to us. Say, for example, we decided that when we did our checking around, we found that there are places that were selling patties for less than 200, right? Say, for example, a place is selling patty for $180 each, right? What would be happening on the other side? And let me see if anybody can figure out what this axis is going to be talking about if we represent this line. So we spent $180, but we're realizing that that is being mapped to $20. What would that $20 represent?
All right, one student is saying it represents the total amount of money. I believe that's money. Thank you. I figured. And all right,
okay.
Someone needs
I'm saying,
go ahead.
Oh, let me repeat the question because I saw it. Okay, we were able to spend $200 each for each party, right? And we found a place that is selling patties not for $200 but for $180, right? But when we spent $180, we realized that there's something happening where we have this $20, that $20 being mapped with the $180. So we are asking, what could this $20 be? And I'm seeing it in the chat. Someone was saying it could be profits. Okay, that's possible. But in this scenario, we are the consumers. So Chevelle is saying $20 would be the change. Okay. The money saved, Tatiana. Good. Good. So I'm hoping you're seeing that. So if it is that we have also, say, for example, let's test that. If we spent 140 each and we are left with $60, would that make sense to us? If this is going to be the amount of money saved for each party. $140 and $60. You're saying no? We're saying person saying no.
Okay, there's some students.
140 plus 60 would not give us 200. All right, persons are disagreeing with the person. Okay, yes. So we are seeing that there is a constant along this line, right? In terms of the relationship between X and Y. If it is that we have X plus, if we have X and Y, if we add the values of X and Y, we get a constant amount, right? So the question is, if it is you wanted to model what this line represents using X and Y, what would that be?
Amelia has something there, sir.
Amelia. Yeah, Camelia. Okay, let's see. We're not sure about that yet. Let's see if anybody else is saying anything. If this line that is being represented would be represented by X plus Y equal 200.
Delano agrees with what Camille is saying. Jada, Abigail, they all agree as well.
Okay. Awesome. So you guys are definitely on point today. So X plus Y is equal to 200. That is what that line represents. And this is an important line because we're going to be seeing this line a lot when we go to our CSET problems. All right, let's jump down quickly and just finish up with this section of the scenario. On Friday, Ashley and Jerome, they got some more money, right? Because we know when we're going back to school, costs are rising, right? And we need a little bit more money for lunch, right? So if costs are rising, we are expecting the parties possibly to rise in cost. I want you to tell me in the chat, what could be the cost of the party now that we are going back to school? It was originally $200, but we know that there's a possibility that the cost may increase. What could the new cost be when we are going back to school? It could be $220. Okay. Yes. Right, that's good. It could be $230. It could be $210, $300. Okay. Okay, so using your algebraic expression, how would you represent all of what you're giving me right here? What, it could be $250, yes. Using your algebraic expression with X being the cost of one party, what would you use? What inequality would you use to represent this? Okay, Michaela is saying X is greater than 200. Okay. Let's see if anybody else agree.
All right, some students are writing it in words. I see Brittany Manning here. And I'm seeing somebody from also on YouTube, Tashi Boo, she said 250. I am seeing where she wrote X greater than or equal to 200. So some persons, Kamika has X is less than 400. And there are a variety of responses here, but I see a number of them implying that that would be X greater than 200.
Okay. And most of them, okay, so could it be 200? Remember, this is just our expectation, you know. We are thinking that it's possible that the cost would be more than 200, but does it have to be more than 200? Could it be 200 when we return back to school? If the original cost was 200? Yes, it could be 200, fine. So that is it. So we wanted you to, we know that the party is going to be at least 200 because we're not expecting them to cut the cost of the party or drop the price of the party, right? So let's see what that would look like on a graph. And I'm hoping you're noticing the differences between the graph that we have here and the earlier graph. Let me see if anybody notices and wants to say what it is they notice about this graph in comparison to the earlier graph.
All right. One student is sharing that it stops at 200 and one ended stopping at 200 and one began at 200. So started at 200 and one stopped at 200. I'm seeing Franklin saying he's not sure. So we're looking, Chevelle speaks to the shading region, which is on the other side, I guess speaking to the right side of the line X equal 200. So we have mixed responses.
Yes, and what most
even
of them
on YouTube as well.
Most of them are seeing it in terms of, first, it is another shaded region as we would have seen earlier, but it is picking up from where we left off, where the other one was at most 200, right? This one is at least 200. So we know that the cost is going to be 200 or more. And if you look at the X values, I'm hoping you're seeing what is happening, that these figures here are 200 or more, or we can say at least 200 or a minimum of 200. And also some persons would have said that it as opposed to the last one, which we shaded this portion of the graph to represent less than 200, we are shading on the other side of the X equal 200 line to represent X greater than or equal to 200.
All right, okay. Kamiko, I just want to squeeze in Camilla White. She's saying that 200 was the maximum price for the first one, stopping at 200, while for this one, at least we're beginning at 200. So we're starting. So here, the minimum cost of a patty is $200.
And I'm liking how she worded it in terms of
yes.
the at least and the minimum and the maximum. So she's true. Getting some of the language we often use when we're working with linear programming and inequalities. So I'll hand you over to Mrs. Edwards, who will take you through.
All right, so I'm going to now pull from what Franklin just shared. Franklin said, so when X is equal to 200, it's shaded then for the lunch money. Now, we're going to be talking about how do you know the inequality symbol and the type of lines that we would actually draw to represent the inequality. So if I'm looking at the less than or the greater than, what will happen here, Franklin or the other students, is that you will see a broken line or what we call a dotted line. So that's the type of line you will see drawn there. Now, for the actual question, we are seeing less than or equal to, greater than or equal to, which means that a solid line is drawn and the cost is actually included. So to answer your question, the $200 would be in the cost, hence the line being a solid line. If the line itself was a broken line or a dotted line, then the $200 would not have been one of the options, all right? So we're now going to be moving into graphing inequalities. And in doing so, we have the line 3x plus 4y equal 12. So that's the line. And notice that we have shaded two aspects on the grid. We have a purple looking pink, and then we have a bluish color here. So what I'm asking you to say, what inequality would you use to represent the pink section, and what inequality would you use to represent the bluish, section? Can you see? So if we're looking at the graph here and we're noticing that it's two different colors. All right, sir, can you tell me what Brittany is saying?
Yes, so, okay. Brittany is saying less than or equal is for pink, and magenta is greater than cyan. So I know someone really knows her colors.
All right, magenta.
Magenta and cyan.
All right, art students. Okay, magenta. All right, so
Brittany is
indeed.
saying, yes. So I'm saying greater than or equal to for blue, for Brittany.
All right, so, so when we are shading the region in terms of where based on the conditions, if it is that we're talking about a region that is less than, we would shade below the line. If we're talking, and then you remember we spoke about the solid line. So in this case, it would be less than or equal to for what we consider. All right, let's go to the magenta. I like the word magenta. So 3x plus 4y, and that is greater than 12 would be the region above the line, because we're looking at above, greater than, and equal to, or equal to. When we're looking now at the region that is below, it would be 3x plus 4 less than or equal to 12. So we want you to pay keen attention to where we would shade based on the inequalities that's given. All right, very good. So now let us look at the CSEC question. Now, I'm going to have you look at the question. The lines are already drawn for you, but two of the three lines, so we see the X and the Y axes there, but there's a line that is not labeled. So we have the line GH that's labeled Y equal 16X plus 5, and the line Y equal negative 5/8 X plus 5. So the diagram above show a triangular region bounded by these two lines, the line Y equal 16X plus 5 and the line Y equal negative 5/8 X plus 5, and also the line HX. Can you give me an equation for the line HX? Sorry, HK.
I'm seeing Brittany, pass out the blocks. HK is X equals 6.
All right, anybody else agreeing with her? All right, Brittany, can you tell us why you have labeled the line HK to be X equals 6? And Camelia?
Other persons are agreeing with her, Faith and Camille.
All right.
Camelia.
Franklin is saying he might go with it. All right, Franklin. Okay. All right. Because there is no y-intercept. Interesting. I like what Brittany is saying. It passes directly through x-axis at 6. All right. All right. So, Mr. Brown, what else can we pick from this line. Yes, I realize that we are agreeing with them that the line HK is x equals 6. Pulling from what was said about passing through the x, passing through 6, and it's parallel to the y-axis. What do we notice for those coordinates for that line?
Okay, Delandra is saying HK is equal to 5.
On YouTube, Cheryl Smith is also saying that x is equal to 6. Very good, Cheryl.
Okay, so there's a consensus around HK is equal to 6. Okay, and we can check that in terms of, as Miss said, the coordinates along the line HK. So let me do a little bit of annotation and see if it is we were at this point on the line, what would be the coordinate?
Look at the marker where, okay, 6, 0.
6, 0.
All right, very good,
Okay.
Brittany.
Okay, let's move up a little bit more. Let's see here. If we are at this point, okay, I'm seeing 6, 4, 6, 4.
But I saw 4, 6 squeezing
I
there,
saw
no,
one,
sir.
yes, one quick 4, 6 flashed by. Not sure. All right, let me see who. Delandro, okay. Not Delandro, sorry. Let me see who said, yes, it was him. Okay, it was an error, he changed it. And at this point, final point we're looking at, the coordinate of this point was going to be okay, 6, 6. So you would have done some analysis here in terms of this. So we'd have had 6, 0, 6, 4, and 6, 6. Can you tell me what you would have noticed in terms of what is common to all of those coordinates? 6.
Yes. So they're
6
all
for which one? The x coordinate or the y coordinate? Okay, so beautiful.
all right. So using the same graph, and we're going to now be looking at the writing inequalities to describe this same graph. So we're going to be moving to, all right, nicely done. So we have labeled all 3 lines. So given that we have labeled all 3 lines, what I want you now to do is to write 3 inequalities that can describe the shaded region. And we're about to put in the shaded region.
Okay,
and then,
let me annotate a little because
yes,
there is something off about the
just shade it for us, sir.
Okay, let me just shade it in. So we're talking about this region within the triangle. So this region, okay.
All right, so I'm seeing for the line, okay, y equal, okay, so a student here is writing that y is less than or equal to 16x plus 5, all right? That's one response coming in. So we're looking for 3 inequalities that will satisfy that shaded region that Sir just annotated for us in red. Okay, y is greater than or equal to -5/8 x plus 5. That's a second one. Do we agree with what is being posted here in the chat? Do you have another way in which you would want to write it? Remember, students, make sure that we're writing down the information being discussed today.
Okay, at Camellia, we were discussing earlier in terms of the different regions, whether or not it's above or below the line. So we're looking at these lines to tell if the region that's highlighted, and let me see, do a little bit of annotation here. So we have this line here, right? We have this line. So I am wanting you to determine whether or not the region that is here is below or above the line y equal 16x plus 5. And that will kind of guide you in terms of determining if it's less than or greater than or equal to.
All right, so
Okay, persons
several
are saying below. Yes, miss.
below. And then I noticed that a student would have shared for the line x is less than or equal to 6. So great job, students. Let's see if those are the same inequalities that we came up with. But great job, sir. So the very first one is x is less than or equal to 6. Very good. That was posted in the chat. The next one would have been y is greater than or equal to negative 5/8x plus 5. And the final one would have been y is less than or equal to 16x plus 5. Great job, students. So though we were given the line, what we were now asked to do is to state the inequality based on a shaded region. So sir, can we just bring in the shaded region now so that they see that we were indeed talking about the part that was shaded in red. All right, great job, students. So when we look now at the actual shading and what we have before us, we realize that the conditions match what was below. We are seeing that it's below the line, and what is above, we are seeing that for the line y equal negative 5/8x plus 5 that we are shading above. So the inequality that would represent that would be y greater than or equal to negative 5/8x plus 5. Great job, students. All right, it's your turn. Let's check your progress. So I'm going to give you a minute or two looking at the 4 options that we have here and what we would have discussed before. Which of the following graphs best represents y take 3x less than 2? Now we're testing what we would have shared before. So which of the options A, B, C, or D shows or best describes y take 3x less than 2? So if we're about to shade a region on the graph, so let's make sure it's simple as possible. So we want to shade a region on the graph. Where would I shade, and which line would represent y take 3x less than 2?
I'm seeing person saying C in the chat, and there seems to be some consensus around C.
Okay, so we're saying C. Somebody said the broken line. Why are we using the broken line here? So we would have eliminated B and D. And I would like to know why we selected the broken line. Because it's less than and there's no equal sign there, all right.
Okay.
If it is that we're looking for the region that is less than the graph, would C show that we are shading a region less than the graph or above the graph?
Okay, persons are now responding A in the chat.
All right, someone
So they have changed their mind. So instead of C. We're now going with A.
Right, so let's look at B. One student or two, I've seen some students on YouTube, likewise, they would have shared C, hopefully when we explain the C. So we're looking at B. All right, so why is it? Okay, so you are saying because we are shading the region below the line, then the option would be B. When we look at the line itself and it speaks to the inequality that is less than, so why take 3x less than 2? Would we be shading, would that line rather be one with dots or one that would be straight? Remember, we took you earlier through in terms of how it is that when we're graphing, the type of lines that we would have, whether it's a solid line or a line that would have been broken or dotted.
Yes, Miss, in the chat they're responding, it will definitely be a dotted line because it is less than and not less than or equal to.
So is it A or is it B? All right, so we saw them now reason it out and coming to the consensus that that representation of why take 3x less than 2 is, all right, we still see Franklin squeezing in B, but remember, Franklin, that there is no equal to this, it's only less than. So when it's only less than or greater than, the line would be broken. However, if it's less than or equal to, where we normally have the stroke below the symbol, then the line would be a solid line or a unbroken line. All
okay,
right.
he's changing his answer now to A based on the explanation.
All right, awesome. So indeed, the answer for this, I'm seeing many persons finally coming around to it, would be A. All right,
Okay.
so why not C? All right, let's just squeeze that back in. All right, Jada, okay, all right, we're gonna go back. So Jada, you're seeing C. However, remember we're talking about less than so it's less than 2. When we're talking about less than as it relates to the line, remember when we did, it was it magenta, I was told the color was that the word?
Yes, it was magenta.
Right, remember when
yes.
we were looking at that diagram and we had 3x plus 4y equal 12, and we're talking about the shaded part, what is below and what is above. We realize that if we're shading the region above, it would speak to that which is what? Greater than. So therefore, because the question here speaks to why take 3x less than 2, we have to shade the region that's below. All right, so hopefully give me a thumbs up. Come on now, people. We want to make sure that when you leave, you know, we are
yes, and I'm liking the interaction in the chat because they're all chiming in and helping out to explain why it couldn't have been C.
And we want, you know, we're wrapping up the series. This is the 6th of 7th. So I want everybody to be on board for next week, the final series. So we want, when you're through with these series, you know, you have mastered certain skill sets. All right, over to you, sir.
Okay, so we'll look quickly at another real life scenario. And this one is near and dear to my heart because my birthday is coming up, right? Okay, so we're starting a decorating company for birthday parties and baby showers, right? The students are able to, the balloon colors are based on the sex of the child. And we're using boys, blue for boys and pink for girls. It sounds interesting. Yes.
So we're planning your birthday party, sir.
Yes, we can either set up the party mainly for girls or mainly for boys. So we know that it's going to be mostly boys or mostly girls, because of course, if it's a male child that's having a party, most of his friends are likely to be boys, but we don't want to leave out the girls. Good. So here are some of the conditions that we would have set up. The number of balloons for which each sex, for which you can choose must be at least twice the number of the opposite sex's designated color. Meaning that if we are setting up a party for boys, the number of balloons for boys must be twice the amount of pink balloons that we have for girls, right? And if we are planning for girls, then the number of pink balloons must be twice, at least twice, the number of blue balloons that we have for the boys. Good? So there are two more conditions. When combined, both colors cannot exceed 15 balloons. And finally, we must have at least two of the opposite sex's color, right? So we'll discuss this a little bit further when we're actually mapping it out. So what we're going to be discussing are what are the possible combinations of colors for one of your events. We'll be looking at one combination that definitely could not work for your event. And we're going to be doing some modeling, right? So here we go. So I would have placed the limitations here so that we have ease of reference. So firstly, we know that we are planning for either boys or girls. So let's see in the chat, who do you want us to plan for, the boys or the girls? Let's see in the chat, who are we planning for? Are we planning a boy party or a girl party?
So I thought we were planning your party.
Well, might as well. So we're going to be planning. I'm seeing girls, I'm seeing boys. Okay. Okay, you guys don't want to help me plan my party? Okay, all right. I want to plan my party.
They're pitying us, so they will go with a boy party. Thank you,
Okay.
guys.
So we are going to plan for a boy party. Good. All right, so let us see in the chat. We have 3 conditions to meet. So we're planning for a boy party, so we know we can have the amount of blue balloons must be at least twice the amount of pink balloons. That's our first condition. And we know the sum of the number of balloons cannot exceed 15, and then we must have at least 2 of the opposite sex's balloon. So let us see what combination, if you will have, type in the chat and we'll take some of your suggestions. How many blue and how many pink would you want to arrange for my party? Given all the restrictions that we have laid out.
All right, so can I just make sure that, okay, good. I see 4 pink, 8 blue, so you can go ahead and write that in.
All right, let me just bring up the annotation in the meantime while they are thinking.
Kimon, so you can just write Kimon, she's the party planner. So 8 blue, 4 pink.
So Kimon.
Right.
Kimon is saying how many blue?
And they're rolling in now. 8 blue, 4 pink.
8 blue, 4 pink. Okay.
And I'm going to go with Shamir. Shamir says 10 blue, 5 pink.
Shamir. Okay.
And 11 blue, Dana, 4 pink.
Shamir is saying what?
Okay, let me jump again. It's 11 blue and 4 pink.
11 blue, 4 pink. Okay.
Okay, and JG. Okay.
GG?
All right, JG, but let's go. We're looking at 10 pink.
All right, JG.
Right. JG had 10 blue and 20 pink, I believe. It's moving so fast. They're just
and 20
throwing
pink.
in. And
Okay.
Shakira has...
So 10 blue and how many pink? 20?
20.
Okay,
I
last
meant,
one.
and the last one is 15 blue and 5 pink. No,
I'm
10,
seeing one.
sorry.
I'm seeing one on YouTube.
Okay, let's take a
We
YouTube
have
off.
one from YouTube.
Let's take the 9 Ordain Grant, Ordain 9
Ordain.
blue and 6 pink, right?
Ordain, thank you.
And let me just, yes, so go ahead with G.
9 blue and how many pink?
9 blue and 6 pink.
And 6 pink. Awesome, awesome. This is looking good so far. So we're having a good party. We're having a good party. All of these party plans for my birthday party. Okay, let's see if Kimon would have met all our requirements. The first requirement is that we must have at least twice. So whatever number this is, it must be greater than or equal to twice this number. So it must be at least twice of this. So when I multiply this by 2, this must be that number or more. So we'd have met that condition because this is exactly twice, right? The second condition we would have had is that the total must not exceed 15. So let us see. 8 plus 4 would be 12. So we would have met that condition. And finally, at least 2 of the opposite sexes color. So Kimon, great job. Great job. I'm liking Simone's party. Kimon, sorry. So Shamir, let's see what you have. For the first condition, this being at least twice. So when we multiply this by 2, we get 8. This is more than 8, so it meets that condition. When we add 11 plus 4, it is 15. So we haven't passed our maximum, which is 15. And we must have at least 2 of the opposite sexes color. So we have at least 2 pink balloons. So Shamir is also on point. Let's see in the chat if anybody is agreeing with JG first before I actually go there. And if it is you're not agreeing with JG, what would you change?
All right.
And why are you not agreeing with JG?
Kimon is saying it exceeds 15, and it's the same thing being said on YouTube, where very early we had Pretty, who was already saying that it cannot exceed 15. So the students are actually looking at the criteria, the conditions that we have, and they were already working with it.
Okay, so we are seeing that we were already having a problem with JG's proposal because we cannot exceed 15. So we know at least one of the conditions was violated. So let's look at Ordain. Did anybody have any problem with Ordain's suggestion? Did Ordain meet all our requirements?
No, let us look at what Ordain has. Okay, we're seeing that it's twice. Some persons are saying no.
Some persons are saying no. Okay, for those who are saying no, let us hear why you're saying, oh, okay. Let's hear why you're saying no.
All right, it's not twice the amount of the pink. So I'm seeing where they're responding that though the total adds to 15, but it is not twice the amount.
So we would have met one of our conditions for Ordain. It does not exceed 15, but our problem would have been with our first condition. Because when we look at twice this amount, this number is not at least twice of this. So this number would have had to be 12 or more. So how would we adjust this though in order to meet the condition? Let's help Ordain out with his planning.
All right, someone is saying we could change the pink from 6 to 3.
Okay, we could change the 6
or
to 3.
4. Very
3 or
good.
4. Okay.
Aaliyah, very good. Camelia.
All right. Let's see if that works out now. It meets the first condition.
All right, so it meets the first condition. Very good. All right. Also, we could have changed it, the 9. Oh, you're talking about JG. All right. So we could have changed the 20 here to 5. Very good. Excellent job, students. Excellent. So they're also giving us some ways in which we could have changed it so that they meet all the conditions. Go ahead, Mr. Brown.
Okay, so I'm hoping that you guys are liking this, and we would have planned some awesome parties here, and you guys definitely do understand how to meet certain constraints and restrictions when we are planning for our parties. So let us see. We had some suggested figures. So let's look at what we had proposed. So we had David saying 4 blue and 2 pink. Question, would that meet our conditions? Okay, persons are saying yes in the chat. Yes, yes, no. Okay, one person saying no, it wouldn't meet our conditions. For Serena, which one of our conditions would it not meet? Because we're looking at it being, the sum being at least a maximum of 15, cannot be exceeding 15. And this number must be at least twice. It can be twice, because remember, so we were talking about greater than or equal to. So it could be twice, but it needed to be at least twice.
Mr. Brown, I am loving the discussion. One student is saying, if is it that we were planning the party for girls, it could have worked. However, because we're planning the party for the boy, it therefore could not stand because it would not meet that criteria. Very good. I like the way how they're thinking. They're processing the thing. They're deep.
They're deep. Very, 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 very deep. So in this situation, what are they saying? This one would meet the condition or not?
So if you're planning for the girl, the student was saying that it could have worked.
It could have worked for the girl party. Okay.
Or we can always consider that. Would it have worked?
Would it have worked? Because if it was for girls, remember, girls, the number of pink balloons would have to be at least twice the number of blue balloons. Would that have been the condition?
So what she had here, if it 4-2, if it was 4 pink and 2 blue, so that was what she was also saying in the chat. But I like the way how they're thinking that because this is the blue party, this is the condition. So they are looking beyond just what is there. So I'm liking that.
So that's good. In terms of the analysis, seems to be on point. So yes, we are at least twice. So we'd have met that condition. This would have been a minimum of 2. So we'd have met that condition as well. And the total would be less than or equal to 15. So David's party seems feasible. All right, let's look at Daniel's. Is Daniel's party feasible? Does it make sense based on our conditions?
All right, we're getting the yes.
Okay. All right, so let's skip down a little bit to Steve. We know Steve is probably having a little problem planning the party, and we want to know which one of the conditions or requirements Steve did not meet.
Okay. So there is a problem. The twice the amount, the students are saying that Steve did not meet that condition.
Okay. Okay. Awesome. Awesome job. Awesome job. I'm liking the discussion and the depth of the analysis, Miss. I think the students ought to be commended.
And let
Good
us
job.
not leave out the YouTubers at all. Likewise, they are sharing. All right. So they're saying yes, they're saying at least twice the amount. Christina, yes, Christina, see that you're on with us.
Okay. So let's take the scenario one step further, because we're wanting to know in terms of profit, money making time. So we are planning this party, right, under the name M-Counts Business Solutions, and we are starting to make some money. We are charging $50 for the pink balloon and $60 for each blue balloon. Based on the choices, and we're using the choices from the previous options, we want to know how much money would have been made, which one would have been the most profitable, and which one of the combinations you definitely advise against, right? So let's put that back up. So this is what we would have had so far. And we know for the blue, it is $60 for each blue balloon and $50 for each pink balloon. And we want to know how much money David would make on these things. Let's start with David.
All right, so student, go ahead.
Yes, so students, how would we determine how much money David made from the blue balloons? The cost of each blue balloon is 60, and the cost of each pink balloon is $50 each.
All right, so the multiplications are coming in. So we're seeing where if the cost of the blue balloon is $60, they're multiplying the cost by 4. All right. And they're giving us some totals as well.
Mm. Okay,
I'm also seeing them calculating the pink balloon. So they're actually going ahead. They're multiplying 50 by 2. So perhaps we just need to ask them to give us the totals.
Okay.
Remember, you're supposed to have your calculator, students.
So we have this so far in terms of the number for the blue balloons, 240 and 100 for the pink balloons. So what would have been the total they're getting?
I see the totals coming in, 340. Let's check with my YouTube. All right, so a number of students sharing it, sir. 240.
Okay, let's give a little bit of time on YouTube for them to respond. Okay, so we have 340 for Daniel, for the party that David is planning, sorry. So Daniel is the next party planner. He chose 10 blue balloons and 5 pink balloons. How much would be the total for Daniel's party, if Daniel is the party planner?
All right, what's the total? I see where they're working out the 400. 600. I'm seeing some totals coming in. So if the cost of the blue balloon is $60 to make the profits, and the pink 50, all right, I'm seeing 850 coming in. I'm seeing 850. So I see now that they're working they're doing the calculations, and it's
Okay.
coming in.
Okay. So we would have had for the blue balloons, he would have made $600, right? And for the pink balloons, he would have made $250. So his total would have been $850. So awesome, awesome job. I'm seeing the chat light up a lot, miss. I'm assuming there's a lot of responses and engagement.
Yes, sir. They're actually doing the calculations and they are coming up with the 850.
And then finally for Sharon, for those who are finished, you can go ahead and work out Sharon's total profit.
And they have done that. They're fast. They're
ahead of us, miss. All right.
They're a little bullet. They're out.
That's good. That's good. All right. So what are we getting for the totals for Sharon before we reveal what we have?
880. Mr. Andrew High School for Girls. They're declaring their schools as well. So a number of them, Franklin is coming on board too. Everybody's on board. So we're seeing 880.
Okay. So for the blue balloons, he would have made 780. For the pink balloons, he would have made 100. So the total would have been, in fact, as you said, 880. But I want to throw something into the discussion before we actually decide who made the most money. Or we can state that from now and then we'll have that discussion. Who made the most money based on our analysis here?
All right, so they're saying Sharon.
Sharon. So Sharon is obviously taking it away with making the most money for her party that she's planning. But there is one other question I have because I'm having a challenge. Right? I'm having a challenge.
Sir Camila Bright, I see Camila here saying the more balloon, the more cash. But I was wondering, you know, okay, so they're saying that Sharon made the most while David made the least. All right, David spent the least. All right.
Someone is saying someone didn't meet the criterion. Which one of the persons did not meet the criterion? Okay, all right, we're walking through. Well, we did Sharon already. We did Sharon in terms of which one of the criterion did Sharon violate? Or which one of the requirements did she not meet? She had at least 2 pink. The total was 15 or less. And the first requirement would have been the blue must be more at least twice. Oh, I see what they're saying now. Someone is saying it's not twice, but we didn't say it twice. We said at least.
At least. So remember now in our students, there are certain words that we are pulling on and we're going to be using those as we move over into linear programming in a few minutes. So we want you to understand what it is when we're talking about at least. What is it that we're speaking about? So the language has to be, understood very early.
And when we are saying at least twice, it means that is the minimum. So in the situation, she has to sell at least 4 blue balloons. Would she have met that requirement? The minimum amount of balloons she can sell is 4. Blue balloons she can sell is 4. Based on the amount of pink balloons that she had. Does she meet that requirement? No, she not sell it. She doesn't sell more than 4 blue balloons.
Remember, we're planning for a boy. So we're planning for the boy. So based on that, the number of blue.
Let me respond to Francis. The condition was at least. At least means minimum. So the minimum she can sell is 2 times the amount she sells for the pink balloon. So she's selling 2 pink balloons here, right? When we double that, we're going to get 4 balloons. So the blue has to be at least or a minimum of 4. Did she sell a minimum of 4 blue balloons? Meaning that she can sell 4 or more. Did she meet that requirement? Yes. So she met the requirement, right? All the others were on the nose because all of them were exactly twice, but the requirement didn't say that we had to be exactly twice. It said that the minimum that we had to sell was twice. Good? So she would not have violated the condition. Okay. So, final question while we're on this side. We are seeing that Daniel and Sharon both sold 15 balloons, but somehow Sharon made more money. Can you help me to determine how it is Sharon made more money than Daniel, although she sold the same amount of balloons? Help me to figure out, tell me in the chat why it is Sharon is making more money, although she's selling the same amount of balloons.
All right, so we're seeing blue balloons more expensive than the pink balloons. All right, so the more blue balloons, the more profit.
Yes, awesome. And that's one of the things we wanted to get out in terms of, because that will help you a lot when you're going to work with your CSEC questions to do your analysis in terms of being able to identify where your profit is coming from and the cost and how that factors into the profit. Okay, so we would have established that Sharon made the most money and she made $880 for her party. Okay, so we're going to be using now what we would have done, and we're going to be formalizing it now and introduce our algebraic expressions or algebra into it. So as we said before, we're going to use the algebra to translate the worded statements into algebraic inequalities. So we have our conditions, and they're in a little bit of a different order than we're used to, but we'll go through them individually. So for the first one, you would have seen the first condition, you must have at least 2 of the opposite sexes color. And we're using X to represent boys and Y to represent girls, the number of pink balloons, and for X, the number of blue balloons. Okay, suppose there's a question in the chat. Let me see if they missed it.
She sold more blue balloons, and blue balloons are $60 while $50 is the cost for pink. Suppose the All right, we're not sure which question, but you can resend the question to us so that we can see current.
Okay.
So repost the question because we're not sure which one. All right, so I'm seeing where someone has 2x plus y.
So x is in no, okay. So let us think about it through. Let's discuss that a little bit. X being the number of balloons, the blue balloons, and we are saying for the opposite sex, we must have at least 2 of them. So what would be which letter would be representing the number of balloons for the opposite sex? Would it be X or Y? If we are planning a boy party. Okay, Y. So we are saying, okay, so we are saying Y. Y is the opposite sex's number of balloons. Good. So this is saying that number must be at least 2. How would we go about representing that with inequalities?
All right, I'm seeing Davia giving us x greater than 2y. And I'm seeing y greater than or equal to 2. That's Kimon. So let's see what else we can pull from them. All right, Caleb is saying lesser than or equal to. But in terms of which one of these statements are we referring to? All right, student, we wanted to move a little bit.
Okay, so yes, we were
Faster.
talking about Y. Good. So we know that Y, being the number of pink balloons, must be greater than or equal to 2. And I saw a number of persons saying it. What was the confusion was whether or not we're talking about X or Y. But in this situation, we already established that we were talking about Y, and that number, which is the number of pink balloons, and we established that that number had to be greater than or equal to 2. So I'm hoping everybody understands that aspect of it.
All right, sir, go to the next one. I'm trying to answer something what Franklin asked in terms of being marked down. So I'm trying to find the question and then see what
okay, miss. So for this question, all we are concerned with is the opposite sex, the number of pink balloons, and we needed the number of pink balloons to be at minimum 2, because we are planning a boy party and we never wanted to leave out the girls. All right, next, okay, so when we combine both colors, it should not exceed 15. I'm seeing they are saying X plus Y less than 15 or less than or equal to 15. Okay. Any other responses? We'll take 2 more responses. Less than 15. So for those who are saying less than 15, could it be 15? Could we plan with 15 balloons? Okay, yes. So it would be less than, so X plus Y less than or equal to 15.
All right, and the last one.
And the last one, this one is now the relationship between X and Y. So we are saying that the number of blue balloons must be at least twice the number of pink balloons. Let's see, how would you represent that?
All right, I'm seeing 2x greater than y. 2x greater than or equal to y.
Okay.
So, sir, for this, where we are saying that the sex that we have chosen, which is the boy, if that should at least be twice the sex of the girl, is there any way to say that, all right, I'm seeing someone else saying 2x greater than y or 2x less than y? All right, let's see if we can bring this up and have that discussion.
All right, let's bring it up and see what they think about this. And let me annotate a little bit so that we can understand what we're talking about. So this is a number of blue balloons, right? And we're saying that number must be at least 2 times the number of girl balloons or pink balloons. Does this make sense? So whatever the number of pink balloons is, when we multiply it by 2, x must be greater than or equal to that number.
All right, I see Camilla is asking about 2y equal x. Or 2y less than or equal to x. So what if we put some numbers there, sir, in terms of what we took from the table? Because we want them to take the transition from what was in the table. And yes. I'm going to give you 2 table values. You don't have to go back, because, but what I'm going to give you from the table, we had...
I think we had 10 and 5.
We had 10 and 5. So 10 and 5 could work. So let's use 10 and 5. So
all right, let's 10, see in terms of this. So we had 10.
And that would be 10 blue.
Is greater than or equal to 2 times 5.
Or we could have used 13 and 2. Because
13 is greater than or equal to 2 multiplied by 2.
All right. So may I just answer?
Yes.
All right. So students, when we were actually planning the party and you gave us the combination, so what we're doing now is to take what was said in words and we're now writing it in as inequalities to so be very clear. So when we selected for Sharon 13 blue and we had 2 pink, and what we have here, sir?
Yes.
I see something on the screen. Okay. So what we are saying, is it that, remember the condition here is saying that at least twice the opposite sex. So if we selected 2 pink and twice 2 would be 4. So would that still fall here as a truth statement? So 13 is greater than or equal to 4. Same thing. We have 10 blue and 5 pink. The statement would be that the total 10 is greater than or equal to 2 times 5. So what we're doing now is writing what was said in words as an inequality.
Okay, so whatever the number of pink balloons, when we multiply that by 2, it should be less than the amount of blue balloons. That's another way of thinking about it, right? So the amount of blue balloons I have, I know that my minimum is going to be 2 times whatever number that is. So when we had the number of pink balloons here, when we multiply that number by 2, that gives us our minimum. Does that now make sense to meet this condition?
And Mr. Brown, if we were to also turn this around, this is what you were saying, that 2y is less than or equal to x. So the number 2 times or 2 times 2, if we're using 13 and 2, 4 would still be less than or equal to the 13. So it either way of writing the inequality work.
This would be less than 13.
Yes.
Less than or equal to 13.
All right, let's see if when we graph it, then
yes,
it would come out a little bit better for them. Okay, before we go to the graph, can you just also simplify and let them understand how it is that we have this inequality?
Okay. This we did by transposition, right? So if it is that we know when we're working with graphs, we normally have y is equal to something. And as we started from the first scenario with Ashley and her brother Jerome, we were saying the order of it is maintained if it is that, depending on the perspective. So x is, no, wait, let me see if I can take up spotlight so you see what I'm saying. So if we are saying x is greater than 2y, or 2y is less than x, it's the same statement. Good. So that is why we re-express this now by, as some persons would say, turn it around, right? So that works. That works. And then we can now divide both sides by 2 to get it to be that. So it's just another way of, so it's just transposing, right? It's just transposing. So we change the order of the sign and we just exchange the direction of it. So instead of saying x is greater than or equal to 2y, we could have said, let me just drop.
Can we say that we're writing the equation in terms of y?
Yeah, we could have wrote it in terms of y. This would be the same statement as this. Are we in agreement with that part? Yes or no in the chat?
All right, they're saying
these
yes.
Two statements are the same.
Yes.
Okay, now that we established that these two statements are the same, how would we find the value of y? If we wanted to express it in terms of y. Divide by 2, good. So we can divide both sides by 2. And we would get y is less than or equal to half x, or x divided by 2. So half x or x divided by 2. Okay, so we're all comfortable now? So these two statements are the same. It's just expressing it in a different way using the algebraic manipulation.
All right, thank you, Camelia. Camelia is saying that's how she was expressing it before. All right, awesome. So let us know, sir, Mr. Brown, take them through the graphing of this. So students, here it is that we're giving you a link to graphing using GeoGebra. Now, what can be done? We're not going to be actually doing the GeoGebra here, but this is the link that we're going to be posting in the chat so that you can actually have it. Persons who are on my YouTube, you can go ahead and screenshot this. So what happens here, you can type the equations in the program itself and it actually draws the graph for you. So once we have done that, we're going to now show you the outcome of this same scenario. All right, so giving you a minute or two to post it there in the chat. And then we can move on to see what the end product looks like. All right. All right, awesome. So it's now in the chat for you. So, sir, can we see the finished product? So based on the discussion that we are having, and several persons, you were asking us what is linear programming. All of what we're doing is actually linear programming. But what we decided to do was take it apart in small bits so that you can appreciate your inequalities and how to represent them on graph and how to look at the feasible regions. So far we will have looked at the number of blue balloons plus pink balloons should not exceed 15. We have looked at that the pink balloons should be at least greater than 2. We have seen that. And we have also looked at that the number of pink balloons should be less than half that of the blue balloons. So we would have graphed those equations, and then now we would have shaded the region. We already took you through the shaded region. Now, before we go into using the graph to calculate the maximum profit, there are 3 points here that's on the graph that we can use to help us to calculate the maximum or the minimum profit. Because one, we spoke of, I believe, David or Daniel with 4.2, or David, I believe, with 10.5, and Sharon with 13.2. Now, here the profit statement that was given, the cost of one blue balloon. So to make a profit, you will have to sell the blue balloons for $60 and the pink balloons for $50. Now, all we're going to do is insert these values, these coordinates or vertices for the feasible region in the profit equation. Now, before we even do that calculation, someone earlier had said in the chat, the more blue balloons that we sell, we will get more profits. Now, based on what we are seeing here, 4.2, 10.5, 13.2, which one of those will give us the maximum profits? And now we're using the graph. All right, so thank you, Ms. Clark. So 4.2 will give us the minimum for sure. Why are you saying that? All right. Not seeing it coming out as yet. So if we have identified 4.2 to give us the minimum profit, which one of the other two will give us the maximum profit and why? Come on, students, you know, we're in the last part, you know.
13.2 in the chat.
All right.
2 persons are agreeing. Caleb is saying 10.5.
Okay, so Caleb, if it is that we agreed that, so, all right, let's clear it up a bit. We have now graphed the inequalities. We have graphed the lines and we have identified the shaded region. What we're using now is the graph to help us to find the profits. Now remember, based on the table, we came up with 4.2, 4 blue, 2 pink. It matched the condition. And we came up with 10 blue, 5 pink, and 13 blue, 2 pink. So what we're doing here is the profit equation is, remember we discussed that it's $60 for the cost of 1 blue balloon, and we worked it out in the table. So what we're doing now is moving from the table to the graph. So if we were to multiply 10 by 60 and 5 by 250, what is it that we would have gotten from the table? All right, 850. Thank you very much, Caleb. So let us now work 13 blue, so 13 multiplied by 60 and 2 multiplied by 50, 880. So we're realizing that the point at which we will get a maximum profit is when we actually sell what? 13 blue balloons to 2 pink balloons. Awesome. Now, what we want to know, move from, is to quickly take you through linear programming which is just tightening up all of what we have said and then go through some past papers.
Okay, okay then, Miss. We're getting to the exciting part. And I'm hoping how you see how I'm all excited about this, because linear programming is my baby. And so far you would have had most of the concepts down in terms of being able to find out which ones are possible based on the restrictions. Also, you'd have been able to see that if it is that you want to maximize your profit, you will want to sell more of the higher or more expensive items. And all of that conversation came up from you. So you made some very good realizations that will help you now with your linear programming. So let us formalize the whole concept of linear programming, what it is about, and what it is used for. So basically, linear programming determines the best outcome based on the linear relationships and the requirements that are represented by those relationships. And that's basically speaking to your inequalities that we would have been modeling earlier. Those requirements or your restrictions, right? Those are the linear relationships we are talking about. So we want to identify the best outcome given all the restrictions and all the stipulations and all the conditions that we would have had, right? And especially in a state where the government makes certain regulations, and I know persons would have been seeing it now, for the taxi drivers, that the government put some regulations in terms of how much persons can be in a space with each other now. So these are some of the real life applications of it. We also use it in business to find the maximum profit, as we would have done already, and to minimize cost. As well as in transportation, we can use it to find a way to minimize the amount of time it takes for us to reach at certain locations based on the restrictions that we have. Okay.
Yes, sir. You're right on point. So students, go ahead.
Yes. So there are a few key things that we need to formalize in terms of our analysis. The language of linear programming, we'll be speaking a lot about that for the next couple of slides. How it is we turn our limitations or the requirements that we have into algebraic expressions, how we plot these, and how we then use it to solve problems. Yes, Miss.
All right, so students, we were looking at terms such as at least, at most, twice. So as we're about to take you through even the graph to speak to the feasible region, the optimum conditions, and all of that. And then we're going to quickly go into some CSEC questions, because I want to tell you that up to all through this party that we were planning, we were actually using the linear programming to actually do the question. We weren't just, we didn't start by calling it that. So we just, as we're about to go into the questions, we don't want it to feel flustered at all. So let's move on, sir.
No, I think they're going to be excited in terms of being able to make the connections between what we would have done so far and what we're going to be doing in the next session, part of the session.
Awesome.
Okay, so there are some key things that we would have discussed so far based on the balloon party situation, and putting up that the graph of it. There are certain things in terms of vocabulary that you will have to know. First, we normally talk about constraints, and that is all the conditions that we need to meet, all the requirements, all the stipulations, and all of this comes from many sources, whether it is we have to meet these constraints in order to access certain discounts, or the government regulation and government policy puts these constraints on us. We have these constraints to deal with, right? So from among those constraints, we can have feasible solutions. And these are possible solutions that we would have come up with based on all of the requirements and the constraints that we are faced with. And I'm hoping that you're seeing something in the graph here, that these feasible solutions are bounded by these constraints. And it forms, in this case, a triangle. Good? Okay.
Yes.
Finally, the feasible region considers all of the possibilities, and that's a shaded area. So those are all the possibilities that we could possibly have for our solutions. And that's in the shaded area. And finally, the key areas that we will be using for our linear programming or optimal solutions, the maximum and the minimum points on our linear programming model. And these are found at the vertices of our polygon that is formed through our constraints. So
all right. Okay, go ahead, sir.
I'll hand you back over to Mrs. Edwards, who will take you through a few CSEC questions.
No, we would have spent the last hour and a half or so, and we would have been looking at the different concepts or contents for as it relates to linear programming. Now let us see how we can put all of that into some CSEC questions. So let's go through the first question, set of questions that we're going to be looking at is May 2004, and it reads, so I want us to be just as sharp as we were before. So a vendor buys X kilogram of peanuts and Y kilogram of cashew nuts. To get a good bargain, she must buy a minimum of 10 kilogram of peanuts and a minimum of 5 kilogram of cashew nuts. Now here's what I want you to do. Write two inequalities that can satisfy the conditions in the question. So a vendor buys X kilogram of peanuts and Y kilogram of cashew nuts. To get a good bargain, she must buy a minimum of 10 kilogram of peanuts and a minimum of 5 kilogram of cashew nuts. So let me see. All right.
Some responses are coming in on the chat. So let's see what persons are saying.
Okay, no greater than or equal to 10, that's X. Well, X greater than or equal to 10. Y is greater than or equal to 5 kilograms. All right, so I'm seeing some persons coming with that. Let's see if some, because they're not, they're writing the less than and then the equal sign. I understand what they're saying. All right, let's see, let us bring up our two inequalities, because I'm seeing where some of the students have shared this. All right, let's look at what we have here. Do you think that these two inequalities satisfy the conditions? If so, why? She must buy a minimum of 10 kilogram of peanuts and a minimum of 5 kilogram of cashew nuts. So the word minimum is there. What does that mean to us though? Because we must be able to see the word minimum and know what part of the graph that would fall into the region, feasible region. Should be no less than, no more than. She must buy that amount or more. All right, I like how that was expressed, Mr. Brown, that she must buy that amount or more. So if you're seeing the word minimum of 10, it means that just as when we were talking about the patty and we said that the cost could have gone up. All right, so the minimum here, she buys a minimum of 10, so X must be greater than or equal to 10 for the peanuts. And for the cashew nuts, Y must be greater than or equal to 5. Very good. Now let us continue. with the second part. So she buys no more than 60 kilograms of nuts. Peanuts cost $4 per kilogram and cashew nuts cost $8 per kilogram. And she spends at least $200. Now, I likewise want you to write two inequalities to satisfy these two conditions. Read it and see if we can come up with two inequalities to satisfy this.
I'm seeing in the chat x is less than or equal to 60.
All right, Franklin, what we're doing is just writing the inequalities. So go ahead, what you were saying, sir?
Brittany was saying x is less than or equal to 60. But my
All
question
right.
to Brittany first, while she thinks about it, is are we only buying peanuts?
No, the big heading here is nuts, but we have two sets of nuts. We have peanuts and we have cashew nuts. So she cannot buy, she buys no more than 60 kilograms of nuts, which speaks to buying both cashew and peanut. What kind of inequality could we use? Give me the inequality for that. All right, thank you very much, Brittany. So x plus y less than or equal to 60. Anybody else? Okay.
Okay, Miss Morrison is saying x is less than or equal to y. But for Miss Morrison, I would want to ask the question, is it that you are buying more, they're told that you're going to be buying more than the other? One of the things that we would want you to read and pick up from the question is, what is the question asking us? That's one of the first things we'd want to know. If she buys no more than 60 nuts, what does that mean? 60 kilograms of nuts.
I haven't seen anything from YouTube in a while. What's happening, my YouTubers?
I'm seeing Leonardo and others who are now saying x plus y less than or equal to 60.
All right. Okay, very good. All right, so let's see what two inequalities we came up with. I'm seeing a few of them putting it in the chat. All right, indeed. So when we're looking at nuts, where we were actually referring to both the peanuts and the cashew nuts. So x plus y less than or equal to 60 is correct. All right. I soon type it in the chat for you. And the cost per kilogram for peanut was $4 and the cashew nut cost $8 per kilogram. And again, we're seeing it coming up beautifully that 4x plus 8y, at least, we're seeing the word at least, remember we're looking at the vocabulary, is greater than or equal to 200. Now, students, when you see expressions or inequalities like these, we can factorize. Can anybody factorize the 4x plus 8y greater than or equal to 200 for me and tell me what would be a simpler expression inequality for this? All right, Brittany is on par indeed. So when we simplify the expression 4x plus 8y greater than or equal to 200, we will end up with x plus, what I'm reading, x plus 2y greater than or equal to 50. That is correct. Very good, Brittany. All right. All right, let's continue. Now, we're about to graph these four. So what we want you to understand, students, when you get the inequality questions, you're either going to be given phrases that you'll have to coin an expression or inequality to show that, and then you'll have to graph it. And remember, when we're graphing the lines, we are going to further identify the common region. So let's look at these 4 inequalities. So the first one we have is x greater than or equal to 10, which speaks to the peanuts. Now, if I wanted to draw the line x equal 10, where would that line x equal 10 lie on this Cartesian plane? All right, so 10, 0. All right, so if we were to plot a point, so that's 1 point on the line, 10, 0. Any other points for that line? Can I get 2 more points for that line? Because we're pulling on something we did when we looked at the line x equals 6 or one of those other lines. 10, 20, awesome. So sir, let us bring in that line. So based on the responses we're seeing, we had 10, 0 as one of the points on that line, and we also had 10, 20. So the x coordinates are the same. So that's a vertical line that's parallel to the y-axis. Very good. Now, if we're talking about the region that is greater than or equal to 10, where would we shade on this graph? To the right. All right, snap, 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 sir. They're going on nicely.
I didn't know what they're doing, you know. It's because we would have gone through it, so they would have got a lot of the linear programming from the
exactly.
prior.
So for those who are worried about the session, you're already completing the session by taking you through the little bits, you know, the way how we broke it up in small chunks. So what about the line y equal 5? Where would the line y equal 5 be? Yes, Miss Clark. All right, so we're looking at 0, 5 as 1. Any other points? Okay, so with the vertical at 25.
25. Mm-hmm.
All right, so 2 things. Let's go to the the line x equal 10 and the line y equal 5. Notice for the vertical line, all the x coordinates are the same for that vertical line that's parallel to the x-axis. So when we plot 10, 0 and 10, 20, all the x values are the same, all the x coordinates are the same. Now we're about to plot the line y equal 5. So for like Kimon, I want you to see that all the y values remain the same while the x values, those x values will be different. So the line y equal 5 will now be parallel to which axis will the line y equal 5 be parallel to? The x-axis. Very good. So if we were now shading y, the region y greater than or equal to 5, where would we shade on this graph? Well, before me even finish them jumping out. All right, above, up, I like it. All right, I bet you're not going to get this one. Sir, let us look at this line now. We want you to graph the line x plus y equals 60. Tell me, how can I graph this line, students? Give me 2 points that can help me to graph this line. All right, you want me to let y be the subject, so you want me to transpose. All right, we could transpose to get y is less than or equal to 60, take x. All right, I'm seeing them putting y equal mx plus c in the chat.
Okay.
Chevelle
is saying 60-0.
All right, Chevelle, thank you for that. So Chevelle, you're saying that if I simply substitute y equals 0, I will actually know the x value. All right, so
yeah, 40-20.
We can check to see if 40-20 lies on that line when we draw it.
Let's see if we can get one more.
Let's see if we can get one more. We can plug in any value into the equation, yes?
30-30, okay.
All right, but here's the thing I want to leave with you, because we want to do 2 more questions before we run out of time. So if I was to substitute when x equals 0, y is 60, that's 1. And when y equals 0, x is 60. Remember, we need 2 points to draw the line. So, sir, let us use the spotlight and mark where when y equals 0, x is 60, and that will be on our x-axis. And when x is equal to 0, y is 60, that will be on our y-axis. We can, all right, we could start there. So I'm going to now give you a quick way in which we don't have to do up a table. All right. So I'm seeing that persons are saying that we have to move a little bit faster. All right, so let's go through this. So when x equals 0, y is 60, and when y equals 0, x is 60. So let's bring in that line quickly, sir.
So we'd have at this point, we'd have the x-intercept and the y-intercept. So we can use the language that we normally use.
All right. That's where I was going. Awesome, sir. Thank you for that. And let us quickly now look at the line x plus 2y greater than or equal to 50. All right, can we just bring in the other line, x plus y? We're going to be doing the same thing when x equals 0. What is y? And we would further simplify that and see where they both intersect the x-axis and the y-axis, y-intercept and x-intercept. All right, very good.
Yes. Brittany said y equal 25.
All right, so I believe they're getting the hang of it. Yes. All right, so let's look at the shaded region. So the graph, the question simply asks us to show or to shade the region that will satisfy all. And you know, very early, I was asking you to speak to the region, whether it's greater than or less than or equal to, above or below. And what we have here is the complete thing. All right, so having done the question, having written the inequalities, having looked at the graph in itself, we have now shaded the region that would satisfy all 4 inequalities. All right,
one
sir?
Quick exam tip, miss, as regards the graphing of it, when you finish, you can check your answer to see if you have a bounded region for the exam. Because under exam conditions, your region for your feasible region is going to be a bounded region. So it's either going to be a triangle or a quadrilateral bounded by your inequalities. So if it is you find that you have a region that goes without a boundary, you can check back to see if it is that you missed one of your constraints or never shaded it properly.
All right, so moving on nicely. Now, the final part of this question before we go into the last 2 questions, this question speaks to the profits. And remember, we spoke about the profit equation as it relates to what we did with the balloons. So the profit on the sale of 10 kilograms of peanuts is $2, and on 10 kilograms of cashew nuts is $5. So using your graph, determine the number of kilograms of each type of nut the vendor must sell in order to make the maximum profit. So here's my question to you. Looking at the graph that we just did, and we have now come up with all the, we're looking at the feasible region. We're looking at the region that is that suits all conditions. I'm now asking, based on that, and we're looking and we're seeing some vertices here that's marked out. Which one of these would allow the vendor to maximize on her profits. So we're looking at some things from the graph. All right. So let's look at the graph. Let us see if we can pull out some things. What if it is that we only sold 10 peanuts and 20 cashew? So we are picking the coordinates that actually supports the shaded region. So that's what we are using to test, because remember that blue section speaks to the feasibility where the profit lies. So we want to say which one of this would allow us to have the maximum or the minimum profit. So we're testing. What do you think we need to have more in order to maximize our profit? Is it more peanuts or more cashew, and why? Cashew, all right. Yes, I'm seeing that's why. Why do you think we need to sell more cashew? It costs more.
It costs more. Yes.
All right, very good. So we pulled that from earlier conversation. So therefore, what about 1050? I realize here that if we sold 10 kilograms of peanuts and 50 kilograms of cashew, that would work. That's the one that has the highest. What about 55? What about 55 peanuts? Would you think if we were to sell 55 kilograms of peanuts and 5 kilograms of cashew, would that give us the maximum profit? So we want you to look at it and see if we can come to some consensus as to which one. All right, no, the least amount of profit. All right.
So the question is, which one would give us our maximum profit of the 4 coordinates that are the vertices of our feasible region?
Okay, so Camila is saying peanut costs less, so we'd have to go with cashew costing more. All right, so let's look at this. So 1050, so several there worked it out and they're identifying 1050, 10 kilograms of peanuts with 50 kilograms of cashew. Awesome job, students. That is indeed correct. All right, so let us look at what would be the maximum profit now. So how would we work the maximum profit out? What information do we have in this part of the question to help us to find the maximum profit? And can you work that? All right, we're seeing persons doing the calculation.
First, Miss, we'd want them to be able to articulate how it is we would calculate the profit.
That's so true, sir. I've seen them putting information here, and so what we would want them to do is to write the profit statement. So let's see if they can actually come up with the profit equation.
Okay, Camelia is saying 50 multiplied by 5 and 10 multiplied by 2.
All right.
So what is the total profit, Camelia, if that is your computation so far? And then for the others, let's see if they can articulate how it is we're finding our profit.
So I'm seeing Camelia here with 250 plus 20, and she's saying that the maximum profit is 270. All right, so Tyron, let us see if we can put the profit statement up. All right, so the profit function that we're using to see the profits for the vendor would be 2x plus 5y. There are times in the questions, Mr. Brown, where they're asked to write the profit equation or profit statement, and they will be given 1 or 2 mark for that. So students, we not only want you to just show the working, but we want you to likewise write a sentence or a statement of this. And let us look at what is being calculated here. The cost of the peanut is $2, and when we actually do that calculation, yes, we're getting 20 plus 250, and indeed, the maximum profit is 270. Very good. Awesome job, students. All right. We're now going to be moving on to one more question, which we're going to be moving a little bit faster, and then the final question for the afternoon. Go ahead, Mr. Brown, you take this one.
Okay, so for our next question, a farmer is supplying his neighbors with X amount of pumpkins and Y amount of melons daily. He has 3 conditions he needs to meet. The first one, Y is greater than or equal to 3. The second condition, Y is less than or equal to X. And the last one, the total number of pumpkins and melons must not exceed 12. They are asking us to come up with an inequality to represent the third condition.
So let us just be clear, you already got the first 2, so it's the third condition we're simply asked to.
The total number of pumpkins and melons must not exceed 12. That is our
high five. We are seeing it. All right. So Dana is out the blocks and she has X plus Y less than or equal to 12. Same thing for Tatiana. All right. X plus Y less than or equal to 12, right? Okay, agree. So other students are agreeing. So by now, students want you to become comfortable with reading the conditions and writing the inequalities. All right, awesome, sir. So great job, students. I see a number of them also on YouTube. They're putting this in. So let's go.
So we're in agreement with your solution. So let's go on and see how it is we're going to be graphing that. We're skipping through it a little bit because we'd have done a bit of graphing before. So we know that the line Y is equal to 2. We know that it is a horizontal line passing, sorry, Y is equal to 3 is a horizontal line passing through the Y axis or intersecting the Y axis at 3. So we can just put that in. All right. The next one, how would we be able to find the line Y equal X? That's one of the important lines that we normally work with. Y equal X. What are some possible coordinates for that line? Where the X value and the Y value are the same. I'm seeing 2, 2. Okay, sounds good. 3, 3, and so on. Okay, so we just needed 2 values to be able to plot that line, right? To sketch that line. So that is the line Y equal X. So our final one is the line X plus Y is less than or equal to 12. Where would we find the coordinates of two possible coordinates of that line? I'm seeing 6, 6, I'm seeing 4, 8. Okay, beautiful. So we would have had this line X plus Y equal to 12. And of course, we'd have done the conversation before in terms of the regions. If it is that we want to be greater than y greater than 3, it would have been above or below the line.
So what we're asking is for the region that would
The region that we're going to be playing, yes, with our inequality.
Right.
So for the region that satisfies y greater than or equal to 3, is it going to be above this line? If it's going to be greater than 3, is it going to be above the line or below the line? Greater than. I'm seeing some person saying below. All right, let us look at it. These values of y, these values below this line, are they greater than 3 or are they less than 3? Because we have some figures there that we can use to help us. Okay, so it must be above the line. These
They're
values.
not saying above.
Yes, so these values of y above the line are going to be greater than 3. Okay. So we can put in our shading of the region. And of course, we can also put in our coordinates as we were instructed once we got to part 1 of the question. So the final part of the question asks us to determine the minimum value of x and y. What is the least amount of melons and the least amount of pumpkins that we can sell? So x being pumpkins and y being melons. Using the coordinates, and they're highlighted in red for ease of use, which one of them will give us the least amount of pumpkin and the least amount of melons? Awesome. So I'm seeing 3, 3.
Yes, they're good.
There seems to be some consensus.
They're sticking it
all
out.
On point. We're all on point. 3, 3. Yes. So that is the minimum. That's the minimum for this graph. The minimum amount of pumpkins and melons that can be sold. Okay. So we have our final question. So I'll hand you back to Mrs. Edwards.
All right, Mr. Brown, the students have held on and I'm so proud of them. I am so proud of my YouTubers. They are holding on. So students, this question was January 2021 and we are in 2021. So what we have seen so far, and we have moved you from 2004 in terms of reading the statements, coming up with inequalities, to where sometimes equations are given and all you're asked to do is graph it. So here for the question for January 2021 that would have gone, you were asked to use a ruler to draw the lines x equal a half, y equal x, and the line x plus y equal 5 on the grid below. So just before we go into the post test, it's just about 5 or so questions because we want to check to make sure all of what we would have done, you kind of understand it. And we really want you to do the question, but let's get to this. We should be able to draw the line x equal a half. So we have the Cartesian plane and we notice that we are going up for 2 centimeters for 1 unit on both axes. So can you say, yes, I'm seeing Brittany saying the line passes through 0.50 or x equal a half. All right, so sir, let us graph this line. So the line x equal a half is parallel to the y-axis, all right? So very good. So that's the first line we would have actually drawn. And by now we are hoping that we would have asked you to have your graph sheets, and in no time we would have wanted you to just draw this up. But guess what? It's going to be on YouTube, Ministry of Education, Youth and Information YouTube page. You can go back if you didn't get the time to graph these quickly enough. You can go back and graph them. What about the line y equal x? Mr. Brown just spoke about that. All right, so we can plot some points when x equal 2, y is 2. I'm seeing that in the chart. When x equal 3, y is 3. So yes, we see that's a slant line and it's passing through the origin. So sir, we can bring this line in now. All right, so we'll have graphed that line. So what about the final line, x plus y equals 5? What is it that we had given you as a tool without using a table to draw this line? We're drawing the line x plus y equals 5 when x is equal to 0. Yes, so we look for 0 on the x-axis and we find y, the value for the corresponding value on the y-axis, which should be 5. And then we also plot when y equals 0, x is 5. So sir, can we bring in that line? So students, we want to leave those tips with you in drawing some simple linear lines. Very
I'm
good.
hoping they are seeing something quickly, Miss. For
Go
the
ahead.
x plus y equal 5, that the y-intercept and the x-intercept.
Awesome. So
They should be seeing that. They should be picking that up. So those are the easiest points for you to find your x plus y equal functions.
So for Brittany, who gave us those, what she was actually using was the x and the y-intercept. So for the y-intercept, what is the value when x is equal 0 and it cuts the y-axis? For x-intercept, when y is 0, what is the x value for the x-intercept? So those are two things that will help you quickly in plotting any of those linear lines. All right, so the question, having done that, remember this was a recent question, you were simply now asked to shade or to label the region R that satisfies these conditions. So here are the conditions. We are now expected to shade or to, let's look at x greater than or equal to 1/2. Is that to the right of the line or to the left of the line? I see Brittany said inside the triangle, right? So she's also on point. We see that she's picking up a lot of skills today. What about the line y greater than or equal to x? Where would we shade? The line above, all right, I'm seeing that coming out. Yes, anybody else? All right, what about the line then, x plus y less than or equal to 5? Where would we shade? All right, so we're looking at below. So all right, let us look at the shading that we came up with, and a number of you are saying this. So we will have shaded here, we have blue in the triangle as Brittany would have shared before, and we're simply going to do what the question asked us to do. It said label the region as, label it R, and that's it. So that would have been the question that was on the exam paper for January. You were asked to draw some lines and we would have taken you through some prerequisites, how to draw some lines and how to identify the regions and even to calculate the profit. Now, before we go, we're ending the session in about 5 or so minutes. What we're going to ask you to do is to complete the post test. So what we have for our YouTubers, we want you to scan the link or scan the, right, so we want you to scan here and you will get access to the actual questions. And then now in the chat, I'm going to post the link for the students who are here. So I'm posting it for everyone. Don't leave us yet. You have done so well. And we are happy that you stayed on. All right, so there's the link for, thank you, Miss Carol, Miss Harris. Thank you very much. So here we have the link for the post test. So click on the link and make sure you access and you're able to answer the questions that are there. And once you have done that, we are also going to be sharing the evaluation link with you. Tell us how the session went for you. Let us know if some of the skill sets that you weren't so comfortable with at the end of the session. If you are given a question on linear programming, you will be able to at least write the inequalities, graph them. So give us your feedback. We crave that this afternoon. So I'm going to put that like in the chat, and I'm now going to hand over to Mr. Brown, who will do the final remarks.
Okay, sorry. Yes, thank you, Mrs. Edwards. So students, you would have engaged with us for numerous weeks now as we take you through some of the core topics of the CSEC syllabus. I hope you guys have found today's session to be very enlightening. I'm sure a lot of you would have picked up a lot of skills based on the work that you would have done in the chat and the responses that you would have given. And I hope you are comfortable having seen those CSEC questions, that you are confident that if you were to see linear programming questions on the paper, you could tackle them with ease. Again, I'd want to thank you on behalf of the Ministry of Education and the National Math team for engaging with us. And we hope to see you at our final session next week, same time, when we'll be going through problem solving. So again, thank you for participating, and it was a pleasure having you.
Remember, my YouTubers, please scan the evaluation form and let us know how the session was for you today.